who actually looked at the PDF that I sent out with the notes from last day's class? I sent everyone the PDF, right? From this?
Yes.
More?
Time?
Did?
Yeah, so.
Good. Anybody else?
Saw.
They saw it, but they actually looked at it, looked at the notes, read it, especially the end when we talked about key concepts. Anyone? The reason I bring this up is I phrased the question purposely in this order: axis of symmetry, the vertex, and x-intercepts. Okay, using the quadratic formula. So if you use the big formula, what do you get? What does that solve for, Dan?
14.
No. What does it solve for in general? When you're using the quadratic formula,
Oh.
what do you use that for? What's the purpose of using it? What's the actual answer that you get? What is it?
X-intercepts?
The x-intercepts are the zeros or the roots. Okay, so that's what they want to make sure clear. And I've docked people technical marks now on the quiz or the summative. Your zeros and roots are just the values of x. Okay, we just want the values of what x is. The x-intercepts is a coordinated point, so it's that root comma 0. Okay, conceptually, it all means the same thing in terms of a graph, but semantically they do mean different things as well. Okay, so you got to make sure you distinguish between the two. Now, in those notes, it said you can actually figure out the axis of symmetry through this formula. X equals minus b over 2a. That's derived from the quadratic formula. And if I had proved that to you, if I had time to prove that to you, I would have pointed it out, highlighted to you. Y minus b over 2a actually gives you the axis of symmetry. So here, what's the value of a? 5. What's the value of b?
Negative 14.
Negative 14. And the value of c? Negative 3. Okay, so we plug in x is equal to negative 14 all over 2 times a is 5. Then we get x is equal to 14 over 10, which is equal to 7 over 5. Okay, so that's a nice property of the quadratic formulas. We can actually get axis symmetry really, really fast. Because we have the x value, how can we get the vertex? Question mark?
Yeah. When you're finding the vertex through the quadratic formula, so you find the two x-intercepts and then you find the axis of symmetry, then how do you find the vertex from there? How do you find the y value?
That's why I just asked, how are we going to find
Oh.
the vertex from there? Adrian.
Question?
Question? Okay.
Is there a reason to keep it in the fraction form?
Is there a reason why we're
Is there a
keeping?
reason why we're like using fraction?
We will always use fraction because it's always going to be more accurate than a decimal. Okay, so we always want to keep our answers as precise as we can. Sorry?
I know like how to get the loss.
Okay. Well, Audrey, you spoke your piece. Sorry, Audrey.
Would you substitute the value for x into the original equation?
Yeah, so we put x into the equation, or the original equation. So here we get y is equal to 5 times 7/5 squared minus 14 times 7/5 minus 3. Okay, so 7/5 squared is just 7 squared, which is 49, over 5 squared, which is 25, minus 14 times 7 is 98, over 5. Now I can see you have to do some fractional arithmetic, so I'm going to convert the 3 into a negative 15 over 5. Then I can reduce my 5. So now I get y is equal to 49 over 5 minus 98 over 5 minus 15 over 5. So we get 49 minus 98 is negative 49 minus 15 gives me negative 64 over 5. So did I answer the question?
Yeah, part of it.
Part of it, I did not answer the question. Some folks in that summative, when I asked for the vertex, left it as that. That's not the vertex. So therefore the vertex is 7 over 5, comma, negative 64 over 5. Okay? So if you didn't realize that x is equal to minus b over 2a gives you an axis symmetry, what you've done is you have to find the roots first, and then take the average of your roots to give you that axis of symmetry. Here I asked it specifically because this way was a little bit faster, right? And we'll see why. Whoa.
Yeah.
Did I copy it twice?
No, I think you cloned it on that.
Oh, I cloned it.
Yeah.
There we go. Oh, this is so fun. There we go. Yay. Okay. So a quadratic formula is, and I was walking around, I was good to see that almost everyone was writing down the formula. You keep writing it down, that's how you remember in your head. Because you need to remember it for your test, not this coming Monday, the following Monday. I falsely assumed it was Thursday. It's not, it's the following Monday. Okay? So it's x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So really this is just an exercise in plugging the numbers. So we have x is equal to minus. So my b value is negative 14 plus or minus the square root. My b value is negative 14, so I need to square that. Minus 4, my a value is 5, and my c value is negative 3. Take that, divide by 2, my a value is 5. Okay? So what I know is that as some of you are walking around, you left the negative 14 not with brackets. So when you squared it, you got a negative number. Okay? It's the value of b. So in this case, the value of b is negative 14, so you have to take negative 14 squared. That number will always be positive because we're squaring it. Okay? So here what x is equal to, negative of a negative just gives us 14 plus or minus the square root of 114 squared is 196 minus 4 times 5 is 20 times the negative 3 is negative 60, so that's going to convert this to a positive 60 over 10. So x is equal to 14 plus or minus the square root of 256 over 10.
14.
So square root of 256 actually works out evenly to be plus or minus 16 over 10. So therefore x is equal to 14 plus 16 over 10, or x is equal to 14 minus 16 over 10. So here we get x is equal to 30 over 10, which is equal to 3. X is equal to here minus 2 over 10, which is equal to minus 1/5. So there are our roots. Was this a lot harder than factoring?
Now when you get used to it.
It is harder.
Yeah,
It's hard to memorize, but you know what? It's easy for us to make a mistake on our calculator or typo with our calculation, right? It's easier to do because if you memorize a formula, you always get the answer, yes. The actual work involved, it was way easier for me to factor. But
So why do you learn
It's harder if you miss out.
why do we learn this way?
Yeah, why do we, like, what's the
Sometimes
point
you
of
can do the
learning
other
three
way.
different methods? It's harder.
Good question. What's the point of learning 3 different methods? Adrian. Options, right? To me, the easiest method is factoring, right? PSI, doing decomposition,
Yeah.
is really quick, right? Next method is completing the square is somewhat almost as easy for me, right? Here, once you start plugging those numbers, you get confused with plugging numbers, look how much writing you have to do. Almost guaranteed someone in grade 10 in this unit test will mess up on a negative sign somewhere and forget to do something with a negative sign, right? I do it, that's how I can guarantee that somebody will do it, right? So while it's easier, you have to take a lot of care using this method, right? But this method exists is because factoring sometimes is not possible for the integers. It's really hard. Completing a square, now I'm dealing with a whole bunch of fractions. If it gets to that case, then that gets really hard, right? The question comes in, well, what are you being asked? If you're just being asked for the axis of symmetry, or you're just being asked for the vertex, I'm going to try to complete the square on that, if I can, right? As opposed to maybe try and go although minus b over 2a isn't too bad, right? Actually, I like that equation. That was a pretty simple one to use. Okay? Any other questions? One thing I should pause. Any other questions? Give you a chance to think. Any questions? One thing I want to talk about is radicals. So a radical is something that's a square root. Okay? The textbook, I didn't realize it reduces all your radicals, but nowhere in it does it teach you how to do it or what it means. When you reduce your radical, that means you try to pull a perfect square within that number, 72. So you guys know what a perfect square is? Remember what your perfect squares are? 1, 4, right? So 1 squared is 1, 2 squared is 4, 9, 25, 36, 49, etc., etc. Okay? So if you can factor your, I think this is called radicand, right? Whatever's in your radical. If you can factor that to a perfect square, do it. So in this case, that's 72 is the same as what? What perfect square can we factor out of there? 9. Actually, you can do one better.
49.
36 times 2. Okay, but you know what? Let's do 9. That's actually a better example. So when I factor a 9 out of 72, what am I left with? 8. So you could rewrite this as the square root of 9 times the square root of 8. So the whole reason why we want to pull out the perfect square out of that is now I could rewrite the square root of 9 as plus or minus the square root of 3. Plus or minus 3 times the square root of 8. So that's how we write that. But we could do one better. Can we break down 8 to 4, right? So here we get it's equal to plus or minus 3 times 4 times 2, which is equal to plus or minus 3 times the square root of 4 times the square root of 2, which is equal to plus or minus 3 times plus or minus 2 times the square root of 2. So that just gives us plus or minus 6 times the square root of 2. Okay? So the whole idea is whatever's in the square root part, try to pull out a perfect square, factor out a perfect square, so you reduce it to something like that. Okay? So that's what we mean by reducing the radical. Questions? I know I just bored you to tears, I can see it. Friday afternoon, period D, we want to learn how to reduce our radicals. I know. Joy in your eyes. So here's a question. I've actually saved you guys from having to write down the question. Take a sheet, pass it back, please. Yes, Marcus?
No, here's the thing.
Can we write it if you want?
You can write it if you want.
Oh, but there's a bunch of them.
Yes?
Like, so when you have something here, like, when you have and you plug in C value, you can like,
Plug in C value? I want to add 9 to both sides. Extra?
yeah, I don't want to work.
Are you going to get the root?
I want to be a
Okay, wait until I this. Okay? So let's take up this question. We have a rectangle, 2 centimeters longer than the width. So and the area is 168 square centimeters. What's the dimensions of the rectangle? I know not the most exciting question in the world. Thank you. So the first thing you want to do, any word problem you get, any application problem that you get, if you could draw the picture, draw the picture. Right? So here, just draw the rectangle. So I'm gonna let W, because obviously we're gonna try to solve something, we're gonna need variables. Right? So I'm gonna choose W. What do you think W is gonna be?
1.
Sorry?
With.
Okay, if I was gonna choose length, I would choose a different letter. I would choose K. So that W equals the width of a rectangle. Right? So here is W. So what do you think my length is gonna be? L?
Or yeah, with
Yeah, right? The length here we're told is really 2 longer than the width. So W plus 2. Okay? So what's the area of a rectangle? What's the formula for area of a rectangle? You guys familiar with the let equation thing? Lest? So equation, what's the equation? What's the area of the rectangle? It's length times width. Right? I like to break down my equations. I don't like to jump right away. Conceptually, I want to see what I'm trying to do. So area is just length times width. So here A is equal to, well, what's my width? Or what's my length? Here's W plus 2. And what's my width?
W.
W. Am I given anything else
Yes.
in the problem?
The area.
The area.
Nor.
The area.
What's the area?
168.
168. Let's go to W plus 2 times W. So now I want to solve for this. Solve means what value for W will make this equation true. What value of W will make this equation true? How can I start? How can I start? Multiply, what am I multiplying? So what do we call that?
Simplifying?
No, it's already simplified in some sense.
Solving.
We want to expand.
Can't you find the square root of 168 and then subtract 2 so that you put it?
Well, if I take the square root of 168, then I have the square root of W plus 2 times W, which I have no idea how to solve for that. Okay, so it's a good attempt, right? But it doesn't get us anywhere. Okay? So, Matthew, why did you say why would you want to expand this? It's nice, it's in factored form.
Get whatever's in the brackets together.
You're in the brackets together.
Easier to make one bracket, I think it's
Sure.
Yeah.
Well, we're not going to have one bracket, actually we're getting rid of the brackets. But how do we solve for equations? What was
Isolate.
special? What would we need it on one side of the equation?
The variable.
Mildred. Yeah, we wanted 0 on one side, right? So what will happen is that we expanded this, so W times W is W squared, 2 times W is just 2W, we're getting something that looks like a quadratic equation, right? So how do I get 0 on the one side now? How do I get 0 on the one side?
How do we get this take away one?
Sorry, what was that, Dan?
You multiply W plus 2 times W.
How do we get W squared plus 2W?
No, how do we get the W squared?
W times W
Oh.
gives you W squared, 2 times W gives 2W.
Yeah.
So how do I get 0 on one side? Kenna? Yeah, so let's subtract 168 from both sides. Actually, you know what? I'm looking at this. I don't like it. We could do this. So I could subtract 168 from both sides. But you know what I'm going to try to do? What's here? Is W squared a perfect square?
Yeah.
Yes.
Yeah. So you know what? I'm going to try to complete the square instead. I'm going to solve this by completing the square.
Wait, does it make a difference which one to do?
No, it doesn't. If you did the other way, then you can try to factor. I'm just seeing completing the square. That's what's sticking on my head right now. Because I see W squared plus 2W. What do I have to add to this to make this a perfect square? I mean, it's almost straightforward, right? What do I have to add to that side to make it a perfect square? W squared plus 2W. What do I need to add here
Minus something?
to make that a perfect square?
Do you do the
168 is 4.
divide by 2 and square
Yeah,
thing to the
Because the coefficient on W squared is just 1. So what's 2
Oh, I thought.
divided by 1 is,
Oh,
so 2 divided by 2,
1.
1, square it.
1.
I just need to add 1 to both sides.
Yeah.
So we get 169 is equal to W plus 1 quantity squared.
Wait, why does that make it a perfect square when you just add 1?
Because from completing the square, the coefficient on W is just 1. We take the number in front of the W, divide by 2. So if we expand this, right, we've seen that this is W squared. 2 times W times 1 gives us 2W. Then 1 squared gives us 1. That was the thing that we learned about completing the square.
Oh, and then.
Right. So now we take the square root of both sides. So we're going to say, well,
Oh,
sorry.
yeah, I was gonna say take the square root of both sides and then just subtract 1.
So take the square root of both sides. Then we get W plus 1 is equal to, the square root of 169 is 13.
Yeah.
That the only answer?
Or
Thank you. Always plus or minus. Now how do I isolate for W? Caitlin, how do we isolate for W? Yeah, we subtract 1 from both sides. Oops. So that's W is equal to this. So W is equal to 13 minus 1, or W is equal to minus 13 minus 1. So W is either 12 or W is equal to minus 14. Do both those answers make sense?
Yeah. No.
Can we have a negative length?
No.
No. So therefore really the width is 12 centimeters. And what's the length? Sorry? 14 centimeters. Right? The negative numbers we discard because it doesn't make sense in this context. We can't have a negative number for a length, for a dimension. Unless we live in the 4th dimension world. So questions are, now, did I have to solve this using completing the square? No, I could have did what we originally said, negative 68. I probably could have factored that. 2 numbers that multiply to negative 68 to add it to 2. And those numbers would have been positive 14, negative 12. Okay, good? Go ahead. Okay. So I'm an entrepreneur. Notice I chose my dad. So I have Welch's. I sell Welch's on the side. Guess how much I sell these for?
50 cents.
Let me see what I have.
Quarter.
If you're feeling lucky, $10.
5
Give it away
cents.
for free.
$4.
Rip off. A little bit of a rip.
$4 a pack.
How about your cup?
Good, but you know what? I actually found 3 people to buy these for $4
You sold up for $4 or something.
each.
No,
It was period C.
Wow.
Size that.
Wow.
Michael Matisse sitting right here, pulled it out.
T-spot, $4.
Okay. So $4 a pack, I could sell 3 of these.
You could just buy the whole box. I have cash.
Hey, you can't do that right now.
$12.
Right? That means if I keep it to like 4.15 in here. Right? But what I discovered is, if I reduce the price of these by a quarter, 25 cents, 6 more people will actually buy it. Okay? So they do, let's say they did market. So let's say I did some market research and I said, you know, if I reduce the price of this by 25 cents, so it's $3.75, 6 more people actually buy it. So how many people would buy these at $3.75 then? Well, 6
10.
plus my original 3.
Oh, 9.
So 9 people will actually buy these at $3.75.
You make 30%.
Right. Pardon?
You make 33.75.
I made 30, so thank you. Right? But what happens, I've discovered, every time I drop this by a quarter, 6 more people will buy it. So now if I dropped it to like 350, I get 6 times 2, which is 12, plus my original 3, 15 people will buy it. So my question is, what price should I sell these at to maximize my revenue? Right? There's got to be a point where I can price these so that I make the most sales. $1? $1.
No.
25 cents.
More.
25 cents?
movie theaters?
You have to solve it, but I said it's around like $2 to $3.
$2 to $3?
At the movie theaters?
No, right
No,
here.
from Japan.
Okay, he did it before the rumor spreads like wildfire, okay?
Oh, that's a snake.
Although he was like drooling when I pulled it out and like,
So you know
$4?
how goes
No.
out?
So, how can I figure out how to maximize the revenue? Okay, so let's put down the situation. So you take us a blank paper, or you could use the scrap, right?
What are the way I don't have it
So for Welch's, right? For $4 a pack,
No,
I sell 3. Somebody didn't clean up after themselves.
And you can give us one, right? Yeah.
So $4 a pack, I sell 3. Okay? Well, I realized for every $0.25 drop, I can sell, or 6 more people want to buy.
What car did you have?
Okay? So how do I calculate my revenue? Let's use green for money.
I can't do that.
Anybody take business here? Or took business in grade 9?
We
How do you
don't-
calculate? Y'all did? How do you calculate revenue?
I don't know. Oh,
Oh,
processing. I mean, cost.
profit minus,
Okay, we're not talking about profit. Revenue is just the amount of money you take in from sales. Right? So how do you calculate for revenue? It's the cost of item. Or sorry, not the cost, the price. That's a better word. Price of an item
The time sales.
times close times what?
It's like the number of sales.
Yeah, times the number of items I sell, right? Times the number of items sold. Right? So there's my equation. Revenue is the price of an item times the number of items sold. So here,
Oh, I found how much, what's the best deal? It's $2 if you sell for $2 worth of
you can explain to me afterwards how you got that, okay?
Well, I did the same thing there.
Okay. Was you trial and error?
Well, I just knew that, like, I knew it wouldn't be the higher ones, I knew it would be the lower ones.
So but you
Yeah.
so it's almost try and error. Okay? So here we're gonna do it mathematically. So we don't have this is like shooting that marble to the cup, right? We don't want to keep moving the cup around, guess, right? We want to solve this mathematically. So here the price of an item is how much? It's $4. Or it's really $4 minus 0.25. Oh, I've got to declare my variable. Let me do that up here. So up here, let x equal the number of price drops. The number of 25-cent price drops. Okay, so let x be the number of times I drop the price by 25 cents. So the price is really $4 minus 25 cents. Minus 25 cents times the number of price drops. Right? So if I drop the price twice, the price is really $3.50, right? If I drop the price 4 times, right, then the price would be $3. Now, what's the number of items sold? How many watches packets do I actually sell? Well, I sell 3 if the price is $4.
3 plus 6x.
Where'd you get plus 6x from? That almost sounds like a linear equation.
It's. I was thinking because this is for every time you. Yeah, it's the same.
Well, no, I want you to explain to me. Why is it 3 plus 6x? It sounds like a linear equation.
Okay, so it's for every time you drop it 25 cents, you get another 6.
Yeah. So every time I drop the price, I sell 6 more. So it is a linear equation, right? The number I sell is actually linearly related to the number of price drops. So I dropped it once, I only sell 9. I dropped it twice, then I sell 15, so on, so on. So how can I maximize my revenue? How can I maximize my revenue? Anyone?
You make it $2.
No. How can I maximize my revenue? How can I solve for this?
Oh,
Geez, what did I just say?
you
What do I have in here with the brackets? What am I gonna get?
solve for X.
Kenna.
Push the solve for X.
Okay, I'm not quite solving for x yet. What do I have here? Audrey.
You need to multiply it out and then once you
Okay, so but once if I multiply it out, what do I get?
you get X and then you isolate X. And
Well, what kind of equation do I get if I multiply it out?
Sure.
A quadratic, right? I'm gonna get a quadratic equation here. I'm gonna get x squared, right? I'm gonna get an x squared if I multiply when I multiply these things, two things together. So I have a quadratic. So essentially, I want to find the maximum value of that quadratic, maximum revenue. So how do I get that? How do I get the maximum value? We could expand it. It'll make your life a little more difficult. What does maximum mean on a quadratic?
Oh,
Sorry, Caitlin?
you factor out.
Okay, and what do we call that? Vertex, right? See how we're tying in maximum to the highest possible point on vertex? So how can we find the vertex on here? How can I find the vertex? Well, I could, but it's already in what kind of form? I already have it in factored form. So I could expand it and factor again.
Oh.
I could expand it and complete the square. I could just leave it factored form. Mildred. Yeah, so I want to find the x-intercept, so I just set this to 0. So I'm going to change that to a fraction. Right? So I want to set it to 0, because I want to find my x-intercepts on this equation. Well, that's just going to be, well, 4 minus 1/4 x is equal to 0, or 3 plus 6x is equal to 0. So I'm going to solve for those. Here I get, well, 4 is going to be equal to 1/4 x. Multiply both sides by 4. And I get x is equal to 16. Or here I get 6x is equal to negative 3. Divide both sides by 6. X is equal to negative 1/2. So that tells me what my zeros are. How do I get my vertex from here? Adrian.
You had access entry, r plus s divided by 2.
Right, so I take these, divide by 2. So here I get 16 plus negative 1/2 over 2, so x is equal to, which is 16 is equal to 32 over 2, minus 1 over 2 divided by 2, which is same as 31 over 2 divided by 2, which is same as 61 over 4. Sorry, not 61, 31 over 4. So at the value of x, I will receive my maximum revenue. So what's x roughly here about? 31 divided by 4? Roughly around $8. For 8 times, I need to bump up by a decrement of, 8 times I need to reduce by 1/4, right? Remember what x stood for? Number of price drops, right? So basically, we want to reduce it. Reduce it by, in this case, 301/4 times 25 cents. Right, what does that give me? What's 2
months.
Sorry. 7.75 times a quarter.
1.937.
Sorry?
1.9375.
9375. Okay. Times. So basically, we'll reduce it by that much. So it's roughly just over $2, right? So if I price these roughly around $2, I achieve my maximum revenue. What would that maximum revenue be?
$102.
So revenue is equal to price, which is $2, and how much would I sell?
51.
Let's get 51.
Just add the 6.
Yeah, 6 times 8 gives us 48 plus 3 is 51, right? And that gives us $102. So that's the maximum revenue I can get. A little bit tricky. Any questions on that? So I need to price it at $2 each.